Bismillahirrahmanirrahim. Now we're starting the third video, which is on IP addressing. Now we've seen in the class that the IP address is a 32-bit address. Okay, the IP address is it's 32 bits in size, and it is used to identify the network, the device on a network. So we have in here so let's say we have a device, your smartphone. It is connected to your Wi-Fi network. Okay, Wi-Fi. It is connected to 4G. All right, and so let's take these two networks for an example. So this is one network and this is one network. So your device will have a unique IP address here and a unique IP address here. So for each network connection, the device will have a separate IP address, and it will be unique for this network. So on this Wi-Fi network, you cannot have two devices with the same address. Okay, so you could have in here 192.168.10.1, and you could have here 10.17.18.22. Okay, so you are having two different addresses at the 2 points. But no other device on the Wi-Fi network can have this address. So an IP address will uniquely identify your device on a network. So the IP address is the address of the connection and not the host or the router. Okay, so always remember it's the connection to the network and not all the device itself. So if the device has 5 connections to 5 different networks, it will have 5 different IP addresses. Now we're looking at the address space. And the address space for IPv4, now how many bits did we say the IP packet had? 32 bits, right? It's 32 bits in size. So how many addresses could we have based on these 32 bits? We can have 2 to the power 32 addresses, IP addresses, right? Could have 2 to the power 32 IP addresses out of these 32 bits. So this is your address space. Okay, this is your address space. So we are basically having 4 billion, 29 million, and so on. Okay, that's the number of addresses we are going to have in the address space created by the 32-bit address. So now we know that each octet in the IP address is represented by 8 bits. Okay, so and we call each number an octet because you're having 8 bits, so it's an octet. Okay, and each one of them, although we are writing it in decimal, it is actually a binary representation. So we are having so when we're talking about converting it into binary, you're having different ways obviously of doing it, but we also have a specific way of doing it, so you can use this in the exam if you like. So these are the number of bits that we have in the octet. So if we were to have 128, put a 1 here and you put a 0 in all places. And what were the other numbers? We have 11, 3, and 31. So we have 11, 3, 31. So 11 would be 8, 9, 10, and 11. And all the rest are zeros. 3, you have 1, 2, and all the rest zeros. And you have 31, which is 16, 8, 4, 2, and 1. And all the rest are zeros. Okay, so this is what it is. So how is the IP address written in reality? You have to write, it is actually all these binary bits. So an IP address is 1, 2, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 1, 0, 1, 1 dot 0, 0, 0, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. All right? So this is actually how the IP address will look like. However, as we cannot remember all these bits in binary, we write it in the decimal notation like this. Okay, so when you are converting an IP address to binary, you must do all 4 of them and not 1 or 2. Okay, you cannot do just 1 or 2, you have to do all 4 of them. Then we know within this IP address, we have some bits that represent the network, and we have some bits that represent the host. Okay, so the part that represents the network is called the prefix, and the part that represents the host is called the suffix. All right, so the prefix is defining the network, and the suffix is you're giving the address to the host itself. Always remember, in a network, your prefix will not change. In a subnet, if you take out some hosts and you make a subnet, a separate subnet, the subnet will not change for the entire subnet network, small network, okay? So always remember, because I know in your assignment, you did the mistake where you changed the subnet bits even though it was in the same subnet. Okay, and we will, inshallah, I will show you, I will go through the homework assignment with you in the video so you understand. But just remember that you have the prefix, which is the network bits, and you have the suffix, which is the host bits. So if the prefix is n bits, the network bits, the host bits, suffix will be 32 minus n. Okay, so this is about the IP packet, the layout of the IP packet. Then we have, now before, when the internet came into existence, we had something called classful addressing. In this case, based on what number you used at the beginning in the first octet, you would classify the address as a class A, B, C, D, or E. So this is what we are trying to show here. Okay, in class A, you have 8 bits allocated for the network, and you have 24 bits allocated for the host. So you could have, in this case, 127 network addresses, and you could have 2 to the power 24 minus 1 host addresses. Okay, because it's 24 host bits, isn't it? So how much will be the address space for the host bits? It would be 2 to the power 24 minus 1. Because, why minus 1? Because you're starting at 0. And whenever you start at 0, you go to n minus 1 and not n. If you start at 1, then you go to n, all right? Remember this. It's very important to remember this. When you start at 0, you always finish at n minus 1. When you start at 1, you finish at n. Now in this case, we have the subnet mask. Okay? And let's look at what the subnet mask is. This is a very important concept. The subnet mask will show you the network bits in the packet, in the address, the packet address. Okay? So if it is a class A, we said, and in the class A, how many? We had 8 bits for the network, right? So our subnet mask for this will be 1, 2, 3, 4, 5, 6, 7, 8, and all the rest zeros. Okay? Because just by looking at an address, in this case, if you go back to this slide, if we were to just look at this address, we don't know whether this is, how many bits are for the network and how many bits are for the host. We don't know just by looking at the IP address. So it is very important to accompany the IP address with the subnet mask. The subnet mask will tell you which bits are for network and which bits are for the host. So in this case, because we're having 8 bits for the network, the class A subnet mask is 255. Right, if you were to add all these ones, they're going to come up to 255. So the subnet mask for class A is 255.0.0.0. Class B, you have 16 bits for the network, 16 bits for the host. So in class B, the network mask is 255.255.0.0. And you have class C with 3 octets or 24 bits for the network and 8 bits for the host. And the subnet mask is 255.255.255.0 in the decimal representation. We can also, instead of writing the whole thing like this, we can also just give slash and the number of network bits. So in this case, the number of network bits is 8. So we can also write slash 8. In this case, it is 16. So we write slash 16 slash 24. Okay, so this is class full addressing. Now in class full addressing, you could not have a network address with, in this case, you're having 8, 16, and 24 bits, right? Allocated for the network address. In a class full addressing, you could not have 7 bits. Not 7 bits. You could not have 12 bits for the network. You could not have 22 bits for the network. You could not have 27 bits for the network. You couldn't have that. Okay? You could only have 8, 16, or 24. You could only use an entire octet for the network bits. And all addresses with class A would start with a 0. So from 0 to 127, that would be classified as a class A address because it is 0 here. The 128 bit is 0. So the maximum we can go is 0 to 127. In class B addresses always started with 10. So based on this 10, you would have 128 to 191. Now let's see how we got that. I keep moving this all the time. Okay. Now let's see how we got that, okay? So once again, putting in the binary bits. And we said the first one was you have a 0 here. So if you have a 0 here, the minimum, the smallest address you can have is all zeros. Okay, you can have is all zeros. So this would be 0. But you know that it always has to be a 0 here for a class A. And the maximum you can go is all ones. Okay, and this will come up to 127. In class B, we said we always need to have a 1 and a 0 here. So if we have this constant 1, 0, again, the least we can have is all zeros. So this is 128. So this was class A, and here this is class B. And the maximum you can have is 1 and a 0 as it is, and all ones. And this comes up. This number will be 191. Similarly, for class C, you have 1, 1, 0, which is 192. It's the minimum, all right? And the maximum again would be, you're keeping this as 110 and all the others as 1, okay? So this is how you had all these classifications in class full addressing. And so now we have the numbers given in here, okay, based on what we could get in the combinations. So this is about class full addressing. But class full addressing, the problem was that you would end up wasting addresses. So you could be assigned a class C address with 24 network bits and 8 host bits. However, your network is a very small network. It could maybe have just 8 devices. Okay, so you're wasting 255 minus 8 addresses in this case. So to avoid that, the industry came up with another type of address, which is classless addressing. Okay, and classless addressing now meant that we could actually have in our network bits, we could have other numbers. Okay, so in classless addressing, you could have network bits like 17, 12, 9. Okay, it doesn't have to be 8, 16, or 24 like class full addressing. You could now choose how many you wanted exactly based on your needs. And this will, of course, save your addresses. And more companies can be allocated addresses. So this is what it shows here, variable length blocks, right? So you don't have just 8, 16, and 24 anymore. And how do you find the prefix length? It is based on these this information at the end. Okay, the slash number that you give here, this number is the length of your subnet mask or the length of your prefix. So in this case, because it's 8, the first octet is network and all the rest is host. 23, 14, 67 to 92. Let's do this. Now always remember, whenever you get an IP address, always convert it to binary. Okay, always convert it to binary and then do whatever you have, apply the subnet mask to it. So let's look at our example here. We have 23, 14, 67, 92. Okay, so we have this. Now let's convert all this to binary first. So in this case, 23, you could do 23 minus 16, okay, which is 7. So you could have 1 of 16. You can't have an 8, so you put a 0 here. 4, 5, 6, 7. And all the rest will be zeros. All right, so this is 23. And then you have 14. So you have 8, 9, 10, 11, 12, 13, 14. And all the rest zeros. And then you have 67. So in 67, you could have 1, 64, and then you're having a 1 there for the remaining 3. Then we have 92. You cannot have 128. You can have a 64, okay? So you're having 28. So 1 of 16. And you have a 12. So 8, 9, 10. So you have an 8. And then 9, 10, 11, 12. You can have a 4. And all the rest zeros. All right? So this is your binary representation. Now let's put this in in the IP address. So you're having 0, 0, 0, 1, 0, 1, 1, 1. And then you're having 0, 0, 0, 0, 1, 1, 1, 0. 0, 1, 4 zeros, 1, 1. And 0, 1, 0, 1, 1, 1, 0, 0. Now how much did we say was the subnet mask? It was 12. Oh my goodness. All right. So we're having 12 is the subnet mask. So now what we have to do is we start from the left and we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And all the rest is 0. All right? So in this case, this is the divide. All this is your network, and all this is your host. Okay? This is why you always have to expand your IP address and then apply the subnet mask. So what is our network address now in this case? It is 23 dot Now, one thing I need to explain to you is, so now this part we said is the network address, right? This is the network address. And if you want to know the network address only, all the host bits have to be converted to 0. So in this case, it's going to be 23, okay? So let me take this first in here. So you have .0.0.0.1.0.0.1.1.0.0.0. We know that this is the network address, right? So if you want to write just the network address, all the host bits are going to be put to 0. Okay, this will be your network address. So you're having here 23.0.0.0. And then you're having the broadcast address for this network would be 23.255.255.255. This will be the broadcast address. Okay, so anytime you're asked for the first and the last address, if you're given an IP address and you're given a subnet mask and you say, find out the first and the last address, always remember the first address, you take the network address and put all zeros in the host part. Then you take the network address and you put all ones in the host part. Okay, my apologies. In this case, it's not going to be 255, okay? Sorry, there's a mistake here. Let's do it again. So we're having 0, 0, 0, 1, 0, 1, 1, 1, okay? And we're having, so this is the network side. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right? So this was the network part we said. Now, if you want to find out the broadcast address, you're going to have these parts as one, all right? So it's not going to be 255. So let's see what it is now. Okay, so it's going to be 23 dot, how much is this? It's the first 4 bits. That is, so 8, 9, 10, 11, 12, 13, 14, 15. Okay? 9, 10, 11, 12, 13, 14, 15, because all these bits are ones in here. So it's 23.15.255.255. So this is the broadcast address and not this one. Okay? This is wrong. It's this one. Are we clear? Okay, do not, so you just leave the network part as it is and play around with these host bits. So this is your broadcast for that network. Okay, this is your broadcast address. And this will be your network address. Let's take another example. All right, let's take another example so you understand it further. Let's look at this one, 220, 80, 24, 255. Once again, 2, 4, 8, 16, 32, 64, 128. So the numbers are 220, 8, 220, 8, 24, and 255. And the subnet mask, is 25. Okay, the prefix is 25. Now 220, converting it to binary, so you're getting in here 92 minus 64 you're getting 28. Okay, so you're having one of this and you're having 16 8, and 4. Okay, 9, 10, 11, 12. And the rest 2 are 0. 8, you're having just 1 in here, and you're having all zeros. And then you're having 24, which is 16, 17, 18, 19. No, you could have one of 8. So let's see now. Yep, so 16 and 8 will make a 24. And obviously, 255 is all ones. So once again, make this into a binary address. So you have 110, 111, 00, 1, 2, 3, 4, 1, 1, 2, 3, 0, 0, 0, 1, 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so this is the IP address that we have, and we said subnet mask is 25. So 25 means you have 24 bits. All of them are network, right? So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And so these are 24 and one here, 25. Okay, so this is where this is all network. Now, if we want to know the first address in this network, you're going to have to take you're going to have to take the network bits, okay, like this. 2, 3, 4, 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, dot 1, okay? So this is your network part. The first address will be, all this will be 0, 1, 2, 3, 4, 5, 6, 7. Okay? This is your first address. And your last address is all this the same, but in here you're going to have all ones. This will be your last address, and it's also the broadcast address. So 110, 111, 00, 00, 000, 1, 000, 000, 11000 dot 1, and so on. So how much will the network address be? And as we said, the network address is also this first address, all right? This is your network address, where all the host bits are 0. So in this case, we're having 228.128. All right, this will be your network address, 220.8.24.128. And what is your broadcast address? It'll be 220.8.24.255. This is your broadcast address. Okay, so this is how you have to convert. So whenever you see an IP address, always make sure you do this, convert it to binary, apply the subnet mask to it. Once you apply the subnet mask to it, just take the network address, put all zeros in the host bits. That will give you the first address. Okay, then you will take again the network bits, put them as they are, and add all ones in the host part. And this will be your last address or your broadcast address. So it's very simple. Once you convert it to binary, things become very simple. So there you go. This is what they're explaining here. Okay, so you have prefix and suffix. You take the prefix, which is your network address, applying the subnet mask. All the suffix bits, when you put them all to 0, that will be your first address. or your network address. Then you keep the prefix as it is and put all ones in the suffix part. You will get your last address or your broadcast address. Now in here we have the example. A classless address is given as 167.199.170.82 with a subnet mask of 27. Now in this case, we want to know the first address, then the last address, okay? So let's do this. So let's gear up and do this now. Once again, you're putting in the numbers. Okay, and what are the numbers? 167, 199. So let's put here 167, 199, and then we have 170 and 82. 170 and 82. Okay, so let's once again convert it quickly to binary and let's see what we get. I want you to practice this so that you're comfortable with these conversions. Once you're comfortable with this, it's very easy to solve it in the exam, inshallah. So 167 minus 128, you're getting 39. Okay, so 39 means you minus 32 from it and you get a 7. And for a 7, you're going to have 4, 5, 6, 7. And all the rest are zeros, okay? Then you have 199. Now, 199, you're going to have 128. You get a 71. So then you can have a 64 and 71 minus 64. And you get a 7 again. So in this case, you're going to have 4, 5, 6, and 7. All right? This is for 199. For 170, you're having your 128 and then 170 minus 128, which is 42. Okay, so you cannot have a 64. You can have a 32. So 42 minus 32, which is a 10. Okay, so you don't have a 16. You have 8, 9, 10, and all the rest are zeros. And for 82, you can't have this. You can have a 64. You have an 18. So you have ones of 16, 17, 18. Okay, and you have all these as zeros. Now quickly put this into the binary format of IP address. 10, 100, 111, 11000, 111, 101, 01, 010, 010, Okay, so we have all this. And how much did we say was our subnet mask? 27 bits. Okay, 27 bits. So you're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. There you go. Okay, so what is the first address in this case? You take all of this as it is. You have 101, 00, 111, 11, 000, 111, 10101010, and you have a 010. Okay, this is your network part. You're going to put 1, 2, 3, 4, 5. This is your first address. And calculate this whole number. Now we know this is 167, 199, 170, okay? Now how much is this one? It's going to be, it's a 1 here, right? So it's going to be a 64. So this is your first address and also your network address, okay? And then we have the last address, and we said for the last address, all these remain the same, okay? 170. Now this is where we play around. So you have 1 0 and you have 1 2 3 4 5. Convert this into decimal and see how much you get. You have 64. So it's something like this, right? 1 2 3 4 5. So you're having, let's see how much it comes up to. Gonna add it up. So it is 64 plus 16 plus 8 plus 4 plus 2 plus 1, and that is 95. Okay, so this is a 95. So what is this? This is your last address or your broadcast address. Okay, so this is how you go about doing it. So there you go. First address is all zeros, last address is all ones. It's very simple. Once you understand this, it's very simple for you to do it. Now we are going to, I'm going to stop the video in here, and I'll make a new video for the next concept.